There we go. So I'm basically here to talk about a work in progress that we've got going at Seagate within CSSG, which is the effects of fragmentation and capacity on Lustre File System performance. And this is a work in progress. So there's only 8 slides. The analysis for the data that we're collecting should be done by the end of this month, and the full data will be presented at LUG 2017 in Bloomington. But so why are we doing this? What is involved? A little bit of history and background. We'll talk a little bit about focus. We'll talk a little bit about our test environment, the nomenclature methodology, and then we'll talk just a little bit, touch on some of the performance tests that we've been running and the amount of data that we've gathered so far. So why are we doing this? Basically, production realities rarely ever match vendor promises, and I work for a vendor, so I can freely say that. I've also worked at customer sites. So typically when we get RFPs or RFIs from people, whether that be Department of Energy sites or oil and gas companies or commercial industries or banks or whoever, typically if you see an RFP or RFI from a vendor perspective, you often see people making assumptions about file systems performance that don't necessarily hold true over the life of the file system. So for Lustre file systems, typically 6 or 12 months into a Lustre file system, you will not find the performance, depending on how you utilize the file system, you will not find the performance matching what you ran during your acceptance period. And that depends on both capacity and fragmentation. And the supposition that we have is the fragmentation in Lustre, even at low percentages of utilization, 20, 30, 40%, can make a drastic degree of impact on what you see for end user performance for applications. And the other reason we're doing this is there are, in case it isn't intrinsically obvious, there are relatively drastic shifts coming in storage models and utilization. And by that I mean a lot of what we're doing in storage today is driven by the transition from hard disk drives to all flash array or SSD types of technology. HDDs are starting to mature, they're starting to evolve, they're becoming a lot more focused on cloud services and cloud storage providers. All flash arrays have their own issues regarding lifetime limited write capability and how they respond to different read and write loads. So each storage block device that you might be using, whether that's a solid state device or a spinning disk, has its own different set of challenges. And that has to be factored into file system design and extended use. So a little history and background. Fragmentation as an issue goes way back. If you look at the file systems literature from computer science, I've got papers that go back to the late 80s, early 90s, discussing file system fragmentation. Despite some of the work that's been done in the past, a standardized way to generate test file system fragmentation doesn't generally exist today. We've been trying to work that in Seagate in Fremont in our lab. There has been some previous performance work done with fragmentation in Lustre. Those folks, I won't go into the details, but some of the work that's been done has been relatively incomplete. So it's not been an effective way of doing modeling. The first instance with ClusterStor, which is our Seagate product, a reported impactful fragmentation encountered at scale was dealing with metadata performance, with a metadata performance decrease. So Lustre can be affected by fragmentation on OSTs, just the metadata. We're not talking about bandwidth here. And dedicated resources have been allocated within Seagate to provide data collection for this problem. So this is kind of what we're dealing with today in Fremont. We've got a small test setup composed of a single storage enclosure, a small number of clients, Lustre 2, 7, and a variety of different utilities wrapped around this, and some Lustre client-side parameters you can see here. So we've come up with a nomenclature. We have a utility, and I can't go into all the details here because we're somewhat time limited. on what we're using and how we're using it, but Matt mentioned Brinzel, which is our previous utility that I discussed a couple years ago for file system benchmarking. That's been modified to allow us to fragment the file system, doing a relatively non-deterministic fragmentation across file systems. So the way we view fragmentation today is different capacities of utilization and different fragmentation levels, non-deterministically, and different ways of generating fragmentation in a file system in the lab. Whether that's a Gen 1 non-deterministic homogeneous file system fragmentation exercise or a multi-phase Gen N pass, which is deterministic and heterogeneous, but it ranks from the extremely simple model to an extremely complex model. And just depends on the amount of time you want to spend in a lab studying this issue. So we have collected some data. The data is under analysis today. We have 2,240 result pairs for our first phase of fragmentation testing. That's composed of direct I/O writes and reads. And you can see here we've got different capacity levels we've run this at. We've got different 8 degrees of fragmentation from 0 to 70% fragmentation in the file system in the lab. 7 different transfer sizes, mostly focused on direct I/O, and 5 iterational passes with each one of these tests. And all of this data is undergoing analysis. And so far, what I can say today is we are seeing some substantial impacts on Lustre at low percentage of utilization, depending on how the file system is fragmented. It's a work in progress. Analysis should be done by the end of the month. The full paper will be presented at LUG 2017. And for folks who can't make it, I'm pretty sure that eventually LUG papers will probably be posted to YouTube or some other internet site. So keep your eyes open if you're interested in this. If you've got questions about the work we're doing, here's my email address, both my ACM and Seagate emails. And thank you very much. Any questions I can answer right now? Yeah.
Hi there. Good, nice work. Is the tool specific to Lustre, or is it a general purpose fragmentation tool?
No, it's a general purpose fragmentation tool. It's written on top of POSIX IO. There's also an API I'm working on for cloud storage to play with cloud storage systems like S3 API. But right now it's focused primarily on POSIX.
Is it open? Can other people use it?
Today it is not open. Eventually we hope to open source it. It's been something I've had for a number of years, but it's based on both. It's a C utility, it's MPI enabled, so it's multi-thread. It uses POSIX threads based on top of the POSIX file system calls. So
okay,
it's kind of like, if you want to think of it as one of my coworkers was one of the original authors of IOR. So this tool allows you to do intermixed block sizes, intermixed operations, a bunch of different things that IOR can't do for you today.
Okay. No, I see a lot of value for the community as a general purpose tool. So.
Right. Okay, thank you. Unless there's any other questions?
Let's take.
Yep.
Just wanted to make sure I understood what low utilization means. Is it that the file system isn't terribly full yet? Is it that it's driving utilization low?
It is. We're doing it based on percent of utilization of total use capacity within the file system. So when I say 70% or 50% utilization, I mean the Lustre file system is showing 50% utilization. We could look at individual drives. We've done block traces, and I won't, obviously all this will be included in the final paper at LUG, but we've also done basically some work trying to determine how we take what we're learning in the lab related to capacity and fragmentation and mapping it back to the real world. Because it doesn't do us any good not to be able to understand how to take what we've learned in the lab and apply it to actual user sites, whether that's Seagate customers or someone else running Lustre. Other questions?
Just real quick, So I assume your testing that you're doing in-house is all on LZFS rather than ZFS? that true?
No, today we're testing with LDISC FS. I hope to get to ZFS because ZFS, being a copy on write file system, has its own issues with regarding fragmentation. If you've used ZFS, you know it has an online defragmenter. I know ZFS is a very popular file system, specifically at Lawrence Livermore. I know you guys at Los Alamos are using it as well, but it really initiated, ZFS underneath Lustre was really a Livermore project. And I would be curious to see how that responds to fragmentation, because I think in production use of ZFS, I think it's going to be a challenge if you start really heavily fragmenting your file system.
Can you give us a quick sneak preview of what the results look like so far in terms of degradation at low utilization?
So far, we've seen 20% bandwidth degradation at very low percentages of utilization, 30%, if varying your fragmentation model. I have a 3D surface plot that isn't complete yet that will be included in the final paper, which is basically it's three-dimensional. One axis is percentage of capacity you're running at. The other one is percentage of fragmentation as represented by the model. And the top end surface for the displacement is bandwidth available after 5 iterative passes. And it's basically a surface plot. And how that surface develops over those data sets will really determine how bad this problem can get for our simplistic model of fragmentation within the lab. Other questions?
Yeah, we'll follow up on David's question. Do you have any plans to publish it, and if so, where? So people, if they're kind of looking forward to
Well, the presentation will be presented at LUG in Bloomington in, I think it's the first week of June. And that will be posted. I'm pretty sure the LUG people, the Lustre user group people, will be putting all the LUG talks online for folks who can't make it to Bloomington. Not that Indiana is not an exciting place to be, but.
Very exciting. I went to Purdue, though, so
Yeah.
they're bad. All right, any other questions?
Thank you very much.
Okay, very good.